Good morning, everyone. In this video, we will be talking about relation between class, state, and interaction models. Okay. So we have already talked about class model, state model, and interaction model. I will quickly try to summarize these things, and then we'll be talking about relationship among these models. So we have seen a class model actually describes the static structure of objects in a system. Okay. We have discussed class model in detail. We have seen the objects identities, okay, what are the classes, their relationships to the other objects. Okay, so we have seen about the associations, aggregations, generalizations, okay, so the composition relationships. We have seen all those relationships, their multiplicity, etc. And we also have seen attributes and operations of classes. Okay, these are the ones actually describe the static structure objects in a system. Okay, the class model actually provides the essential framework into which the state and interaction models can be placed. See, state model basically describes about the changes, okay, among these objects. Until and unless the class model defines these basic data structures, their static structures for that. Okay, what do the changes mean? Okay, that's why this class model basically provides the essential framework. It is the most important of the three. And most important concepts of the class model are the classes, okay, as I already mentioned, and the associations and the generalization relation. Okay, these are the relationships which we have already seen. Then in terms of the state model is concerned, the state model actually describes those aspects of the objects that are concerned with time. Okay, events that mark changes and states that define the context for those events. Okay, so the state model basically describes these aspects. Events actually represent external stimuli and states actually represent the values of the objects. Okay, so we have actually seen in state diagrams how the things actually move. Okay, so how the object basically changes across the states. Actually, objects stimulate each other. Okay, this external stimuli has to come from somewhere, the events. So it is again the objects which actually generate this external stimuli. Okay, that's the events. So objects stimulate each other, resulting in series of changes of their states. That we have discussed these things in detail. Basically, state model consists of multiple state diagrams. Okay, one for each class with the important temporal behavior. Okay, this we have already discussed in detail. Actually, a state diagram describes the collective behavior of all the objects of a class. Say, for example, there is a class, there can be multiple objects, okay, and these objects can be in different states at any particular instance in time. Okay, so that's why a state diagram actually describes the collective behavior of the objects in a class. Okay, so how all the objects are behaving at a particular instance in time. Then the third one is the interaction model. The interaction model describes how objects actually collaborate to achieve the certain results. Okay, we already have discussed the interaction models in detail. Okay, and also different types of interaction models also we have discussed. Okay, let me quickly summarize them. But interaction model actually, it's a holistic view of the behavior across many objects. Okay, whereas if you think in terms of the state model is a reductionist view that examines each and every object individually, how it is actually changing across different states. Okay, how it is behaving, each object individually is behaving. Whereas interaction model provides the complete holistic view of the system, okay, across many objects. But both state model and interaction model are needed to describe the behavior fully. Okay, it is not okay, so one is important, the other one is not so important. Okay, so you need to understand both the models, both state model and interaction model are needed to describe the behavior fully. Of course, we have seen interactions themselves can be modeled at different levels of abstraction. At the very highest level is this use case, which actually describes how a system interacts with outside actors and what are the different pieces of functionality that are existing within it. Okay, And these use cases also help us in capturing these sort of informal requirements at very high level. We have seen like how each use case we take and we describe all the messages that are happening. Okay, so within a use case, okay, and all the steps that happen in detail. And we also have seen like how the error conditions can also be observed. Okay, so we have to define all the things. So more or less like these things will capture informal requirements. Then the sequence diagrams actually provide more detail and show how the objects interact and how the objects that interact and also like time sequence of their interactions. So how these objects interact and also like across time like how they are actually interacting. We have seen the sequence diagrams. We discussed them in detail as well. Okay. Then comes these activity diagrams which provide further details. These things provide actually finite detail and show the flow of control among the processing steps of a computation. So we have seen like how we can actually even define an algorithm or a workflow to that level. Okay, so activity diagrams provide such finest details. So these are the three different models: class model, state model, and interaction model. Interaction model again has different levels of abstraction, use cases, sequence diagrams, and activity diagrams. Okay, right now you already have got about the relationship among these models already. But let us look at them in detail again. Okay, let us try to put all the things together. Actually, all the three models, okay, class model, state model, and interaction models, all the three models actually involve the same concepts. They are talking about the data, how the data is actually, I mean, like sequencing. Say, for example, like the objects, how these things actually move across different states or something like that. Okay, so the data and the sequencing, and then like the operations. All the three models, okay, so are important. That is very clear. Okay, they are all the three models are necessary for fully understanding the system. But each model focuses on a particular aspect and leaves other aspects uninterpreted for that particular thing. And the balance of importance of each model also varies according to the type of application we are developing, according to the kind of applications we are developing. Okay. Say for example, for certain applications like we may have to focus more at the class model, and for certain applications we may have to focus a little bit more at interaction models or even the state models. It always depends on the kind of application. So in that sense, like each model describes the aspects, one aspect of a system, but contains references to the other models. Okay. So basically the class models describes the data structure. Okay, that's what we have been talking about, on which like the state and interaction models basically operate. Okay, so this is the actual relationship among these three models. The class model actually describes the data structure on which like the state and interaction models operate. The operations in a class model actually correspond to events and conditions. We have seen them in state models. Okay, and with respect to activities as well. And activities also have these sort of guard conditions and those things. Okay, so the operations in a class model actually correspond to these events, conditions, and activities. The state model actually describes the control structure of the objects. Okay, so basically it shows the decisions that depend on the object values. Okay, so what is the current state which actually uh, uh, defines the decision. Okay, so what is the current state? And these decisions in turn cause changes to the object values, and that's how like subsequently the states also change. Okay, so the state models actually describe the control structure of objects. The interaction models actually focus on exchange between the objects. Okay, so exchange between these different objects and provides a holistic view of the operation of the system. Okay, that's what we have seen with these sort of use cases, and of course like the sequence diagrams and activity diagrams. Okay, so that's about the relationships of these three models in general. But we have seen like generalization and aggregation are the relationship that cut across all these models. So we have seen generalization. Okay, so generalization basically shows specific variations on a general situation. Okay, We have seen generalizations at class generalization, so the subclass and superclass relationships, so the base class and then like the subclass relationships. So basically, the base class will have these sort of general features, and then like which the specializations, I mean the subclasses are actually extending, are inheriting, and then like they are showing additional features. Okay, that's about the class generalization. Then we also have seen the signal generalization. So the same sort of generalization relation what was there in the classes, we also had seen across the signals in the state models. Okay, so we have seen like how these signals can also be arranged in hierarchy, okay, in generalization hierarchy, and we also have seen like how basically like the generalization hierarchy actually gets the attributes from these signals from higher levels. Okay, so in that sense, like we also have seen like each and every signal is the leaf of the signal generalization hierarchy, and of course like a signal of low level can also trigger the signals of these sort of ancestors. Okay, so we have seen that signal generalization of the data. And we also have seen use case generalization. The similar sort of generalization what we were seeing at class generalization, we were also observing at this use case generalization in terms of the interaction models is concerned. So we have seen like how a particular use case can be extended. Okay. Okay. So we have seen the generalization relationship, and then like then we have seen like how a specific use case can replace the more or less like the super use case, okay, the parent use case. So we have seen the generalization relationship as well. Again, like aggregation relationship also we have seen across different models. Okay, these things basically break assembly into orthogonal parts, which we have seen like a car may be constituting of multiple parts. Okay, so an engine. Okay, so and different parts. Okay, okay, so that is object aggregation we have seen. Okay, much more thing like we have also seen like the composition as well. But then like general, we have seen like object aggregation. So how it is an assembly is constituted with multiple parts. The same aggregation relation we also have seen with the state aggregation. Okay, in the state models as well we have seen like how a class, okay, an assembly with multiple aggregations. Okay, each of these parts can have their own states, isn't it? Their own state models, and we have actually seen like the state of the complete assembly at any particular time actually constitutes, so basically like the state of each and every part. Okay, so this also like we have discussed in detail. Okay, that's how like all these three models are actually related. Hope with this video might have made all the things clear for you. Okay, so how the class models, state models, and interaction models. Okay, so how the class model defines the general structure on which like the state models and interaction models are basically working with. Okay, so all these things we have discussed in this particular video. So regarding the references are concerned, this is about chapter 9 from this object-oriented modeling and design with UML. Okay, with this one like unit 4 of this course is actually finished. Okay, thank you very much for your attention.